this video is the continuation of this packet on changes in concentration with time. So before this, we had covered first order reactions and the integrated rate law and graphing a first order reaction. And so this is the continuation. We're going to discuss second order. And then I'm going to add in zero order. It's not on your paper, but we'll just make a place for it. Okay, so pick right up where we left off. So second order reactions, of course, is a situation where the rate depends on the concentration of a reactant raised to the second power, like this example. Okay, so one reactant and the order is 2. Or it could be 2 reactants and they're each raised to the first power, right? The overall order in this case would also be second order. So we have kind of 2 situations this time. But regardless, we're talking about that this is a second order reaction. And just like we visited the idea in first order, we can do some calculus and we can come up with this thing called an integrated rate law. And this one looks slightly different. And so I'm going to go ahead and write it. We know what's coming is slope-intercept form, and so I'm going to go ahead and write it in that way. And this time, it might make you happy to know that there's no natural log. It's kind of nice. Okay, so the integrated second order rate law looks like this. All right, so it's 1 over the concentration of A at some time t equals K, the rate constant, times T time, plus 1 over the initial concentration of A. Okay, so if you want to label those, you can. But again, this is in slope-intercept form, so this is Y. This is M. This is X. And then this whole thing is B. So, of course, we can talk about graphically, just like we did before. So this time, if I graph, if I have some data and I graph it, my y-axis this time would not be the natural log. It'd be 1 over the concentration of A at time t. Okay. My x-axis, though, would still be time. And notice this time my slope, which is K, is positive. So this graph we'd have a positive slope and it would look something like this. It'd be a straight line. And so let's see. M would be equal to K. It's kind of funny, isn't it, to write like that? But anyway. And my y-intercept here, which would be B, would be equal to 1 over the concentration, the initial concentration of A. All right. So again, what's the takeaway? The takeaway is a 1 over the concentration of A at time t versus time will be a straight line if the reaction is second order. Okay, this is the takeaway point. So prior to this video, we had learned that the graph of natural log of A versus time would be a straight line if it was first order. And now we're learning that the graph of 1 over concentration versus time would be a straight line if the reaction is second order. Okay, so we've got 2 situations graphically, and I'm actually going to introduce a third, which is going to be 0 order. And so you can add this, like, you can put it right here if you want in this space, or you can put it underneath this little practice problem. It's just super small. Okay, so whatever you want. But I'm going to say 0 order. Okay, in a 0 order reaction, of course, the rate doesn't depend on the concentration. And so there's, I don't really have an integrated rate law for you for this one. It's just very simple. This one, if you graphed concentration, pure concentration, versus time, of course, if it's a reactant, concentration can decrease, okay? So your slope would be negative. But in this case, if their line was straight, it would indicate that it was 0 order. Okay, so 0 order is concentration versus time. So let's do a little summary here. and this is what will go like on a takeaway sheet. This is what the AP test will expect you to know right here. Okay, which graphs are straight lines for the 3 types. So zero order, it's concentration versus time. First order, it's natural log of concentration versus time. And second order, it's 1 over concentration versus time. Okay. I mean, the AP test, sometimes in multiple choice questions, they'll give you a graph that looks something like this. Okay, and they'll say, what can we conclude about this reaction and this reaction's order? Okay, and if you know your 3, 1 over concentration is a straight line, you'd have to say this is second order. Okay, so that's the type of questions that would be asked of you in a situation like that. And so the next part of this, now there's a practice problem at the bottom of your page, and it says, the following data was obtained for the gas phase decomposition of nitrogen dioxide. Is this reaction first or second order? And they give you a reaction, they give you some time data and some concentration data, but then you're like, I have no idea. How am I supposed to know? Well, you'd have to look at this graphically, okay? And so this is where Excel comes in, because nobody wants to graph this stuff by hand, and no one would ever expect you to. So the next discussion is a discussion of how to use Excel, how to graphically, how to graph reactions, I guess, in Excel, and then how to determine their orders, okay, using Excel, which is, once you learn how to use it, it's pretty simple. So in a following video, I'll be showing you how to use Excel. I know you have one more note page here. It deals with half-life, which is kind of a standalone topic. So, so that'll be a separate video also. And, yeah, so I guess that concludes this video, but this is the big takeaway point, okay? That graphically, I can determine reaction orders by knowing which of these 3 things versus time would give me a straight line, okay? And that'll all be connected when we look at graphing in Excel.